Welcome. This video is going to be covering the Triangle Proportionality Theorem. The learning target for this lesson is for you to understand the relationship between the length of a triangle. Your three success criteria are: 1. To use proportion to solve for the missing side of a triangle. 2. To prove that two lines are parallel using the proportional of the length of that triangle. And 3. You can apply the Midsegment Theorem to find the missing length of a triangle. We'll start off with a review of your 7th grade standard. First thing is to understand what a ratio is. A ratio is a comparison of two things. In the picture below, they are comparing the colors of crayon. So on top is the 2 that represents the red color of crayons, and on the bottom of the fraction, it is the 5 blue crayons. So you could write it as a fraction. The 2's on top, and we do the divide symbol, then 5's on bottom. The unique part about a ratio is that if two things are the same, you can put them into an equal sign. When you set two ratios together, they become a proportion. So a proportion is basically an equation that states that the equations are equivalent. That means that the left ratio is equal to the right ratio. Something useful that we do from once we set up a proportion, something like A over B equals to C over D, is that you can solve for it by cross multiplying. Cross multiplying means just getting rid of the fraction. So you if you had something like 2 over 3 equals to 4 over 6, you can cross multiply. So 2 is going to be multiplied to the 6 and 3 times the 4. Okay? This is how it looks like in terms of algebra. Make sure you know how to cross multiply, because that's how you're going to be able to solve for a proportion. Alright, so let's do some exploration here. First of all, I would like you to draw triangle ABC and label it. It should look something like this. Now, measure it and label the length of each side of your triangle. I have 9 inches here, 18 inches here, and 21 inches here. Please understand the image on your screen is not drawn to scale. Next, the bottom side of the triangle is a straight line. Construct an other line that is parallel to it by drawing a line through the triangle. If you drew the line straight down, that's not parallel. Okay? So the line has to go like that. Please understand that the red arrows here indicates that it is parallel. Now, once I cut it with that extra line, remeasure each part. The left side became 5, which is the top part, and 4 on bottom, because remember, this was a total of 9. On the right, it's 10 on top and 8 on bottom, because remember, this made 18. What do you notice and what do you wonder about this relationship? Look at the sides and see what you can determine. What you should notice is that the ratio of the left side is equal to the ratio on the right side. That is 5 divided by 4 is equal to 10 divided by 8. What that tells us is this. If a line is parallel to one side of the triangle, that is this part that they're referring to. This is the parallel part. Okay, and intersects the two sides. So do you see these are the intersections? Then it divides the sides proportionally. Do you see this is the side? And when it divides, it means it cuts it. Same thing here. It cuts it evenly. Okay, so this is your left side, and this is your right side. Okay. So let's look at an example. Here we're asking to solve for the missing side. Notice it says it's already parallel, and our question mark is going to be your x. So first step is to set up the proportion. Here I got 6 over 2 over 9 over x. Remember this, if you would like to see how it looks like, it should have been p over s divided by s over q right here. P over s divided by s over q is going to be equal to the first part P over T divided by T over R. Okay, that's how I got this. Okay, then next we want to, the left ratio again describes the left side of the triangle, and the right hand side describes the right hand side of the triangle. Now you can cross multiply. So 6 times x and 2 times 9. That's what it means to cross multiply. So 6 times x is 6x, 9 times 2 is 18. Then we divide by 6 to both sides. You get x equals to 3. So this equals to 3. That makes sense because take a look. 6 over 2 equals to 9 over 3. Does that make sense? 6 over 3 breaks down to the number 3. 9 divided by 3 is 3. So it works. It checks out. Let's take a look here. This is the first practice problem. In this diagram, we see that line QS is parallel to line UT. What is the length of RQ? So this is your unknown here. Okay? So give this a try. Here's the solution. First of all, set up the triangle relationship. I wrote the letters here to represent it. Now I plug in the values. Okay? Here I wrote that PQ is going to be divided by QU is equal to RS divided by ST. Plug in the values here. Now we cross multiply. Okay? We cross multiply. So it became 6 times RQ is equal to 4 times 9 is 36. Then they divide by 6. That's how you got RQ equals to 6. So here we would say that x is equal to 6 here. Okay. Good. So now I would like to give you a chance to do this. Pause the video and give 3 and 4 a try. All right, here are the solutions. So I set up A equals AB is going to be divided by BC. Then I equals to ED divided by DC. Plug in the values. So AB is what I'm trying to figure out. Divide by 3, 12 divided by 4. Cross multiply. That's my cross multiplying. 4 times AB and 3 times 12, which makes 36. Then I divide by 4, I get AB equals to 9. So this is 9. Number 4. Again, here's the solution. Set up the equation. AE is equal to AE divided by ED is equal to AB divided by BC. Once you plug in the numbers, so 14 divided by 12 is equal to AB divided by BC, which is 18. Cross multiply here. 4 times 18 gets you 252. 12 times AB just becomes 12AB. To get AB alone, you would have to just divide by 12 to both sides here. So 252 divided by 12 is 21. That is what you get here for AB. Good. Next, we want to look at the converse. Remember how all the problems before, it states that the image is already parallel by looking at these symbols? The converse of it is that we can actually prove parallel lines. So as long as this is proportion, like 5 over 4 equals to 125. Do you see that? And 10 over 8 is equal to 125. As long as the left ratio is equal to the right ratio for the triangle, you can prove parallel lines. All right? It's the converse of that. So let's see how it looks like. Are these two lines parallel? Notice they don't have that symbol. They don't have this. Okay? Because we're trying to prove if it's parallel. So again, we set up the equation. LM, so I did LM divided by MG is going to be equal to LN is equal divided by NH. Plug it in. So 56 divided by 21 is equal to 48 divided by 16. if you simplify it, look, it becomes 8 over 3. That equals to 3 over 1. These two aren't equal. If you don't see the fraction, just put it in the calculator. 8 over 3 in the calculator is like 2.66. And 3 divided by 1 is just 3. Notice, 2.66 is not equal to 3. The fact that because the left side is not equal, that's what the equal sign with the hash through it, with the right side, you would say that MN is not parallel to GH. So now I would like you to give this a try. This is the practice problem. Give this a try. Remember to set up the proportion. All right, here's the solution. I set up PR divided by RT is equal to PQ divided by QS. So that is 15 divided by 21 is equal to 17 over 23. I reduce it in a decimal so I could compare it. I saw that the left side here is not equal to the right side. Okay, it's not equal to the right side. That's why I would say that RQ is not parallel to TS. So I would say that these lines here, do you see that? TS and I would say that these two lines, TS and RQ, are not parallel. Let's look at 4. Here's the solution. I set up the ratio as PR divided by RT is equal to PQ divided by QS. Plug it in, simplified. 6 over 12 is a half. 4.4 divided by 8 is a half. So here, the left side is equal to the right side. And the fact that it is equal to the right hand side, we would say that these two lines here, which is RQ, is parallel to TS. Because they're parallel, we draw the parallel symbols here with the arrows. Good? All right. Lastly, it's the triangle midsegment theorem. So what it means is that if a segment joining the midpoint, so here's the midpoint and here's the segment that cuts through it, it says that as long it joins the midpoint, okay, so this is the midpoint, which is in the middle, okay, all right, then the segment to the third side, which is this, is half as long. So what does that mean? Okay, so take a look. Whoop. So if this, let's say, was 20 and you cut it in half, this has to be 10. That's what it means. Okay, so do you see how 10 is equal to 1/2 of 20? That's what this says in this theorem here. Okay, or you could say that it's 2 times 10 is equal to 20, right? That's the BC part, right? So that's what it means. That's how you can determine the sides. It always works like that, okay? That middle line segment is always half of the bigger base of the triangle, okay? So let me give you another one as an example. Like if this is like, let's say 100. If you cut this right in the middle, this is 50, right? Or if this is, let's say, 2, this has to be 1, right? And I could even do it backwards. If this is like 3, this has to be 6, okay? All right, so find the length. We know that this is 10, so here's the solution. Set up the proportion. So I would say that QS, right here, is going to be equal to half of the PT line, which is 10. So plug it in. So QS has to be 5. There you go. It's that simple. Good? All right. So set up the equation and solve for it. Again, just set up the equation because I might make the problem harder next time. So just set up the equation. So here you would write P is equal to 1/2 of the 16. So P equals to 8. That makes sense, right? Because if this is 8, this becomes 16. Because this is right in the middle. And the right hand side You do 14. If this is 14, what is this? It's going to be what? We have to multiply it by 2. That's what I did here. So cube becomes 28. Okay? All right. So there you go. That is everything that you need to know about the triangle proportionality theorem.